Take it away, Joe.
Thank you so much, Jeff. Any other words you want to say as we get started here?
Nope, I'm all done. Go ahead. You may start, Joe.
My honor and privilege. I'd like to talk about digital self-management, which I was shocked by when I became a Tesla employee in 2020. I'd been consulting to Tesla since 2010, but didn't join the company as a W-2 employee until 2020. And when I did, I found I had a manager, but who that person was sometimes changed twice in a day. They would rotate through. And then later, I looked at my phone, all the apps that had been downloaded onto my phone when I joined the company. And there was manager training. And anyone who completed the training could rotate through the pool of managers. And I found that Tesla's AI software had basically replaced what I'd been used to thinking of what a manager was. Now, since then, it's been 2.5 years, and the artificial intelligence that we can access outside the company is profoundly increased. Now, ChatGPT is currently the hot item. Now, that's a company that was co-founded by Elon Musk, but Elon's no longer involved. And in fact, Elon is very critical of OpenAI now, even though Elon helped create the company. So I'm going to attempt a live demo. I'm going to go to Chat OpenAI, see if this actually works the way I want. Log in, just as anyone else would in the world. And I'm going to type, who is Joe Justice? Joe Justice is an entrepreneur, consultant, and speaker who is best known for his work as a pioneer of agile methodology in the field of automotive manufacturing. He is the founder of the company Scrum Inc. and the co-founder of WikiSpeed, an organization that uses agile principles to develop fuel-efficient modular cars. Justice has also been a TEDx speaker and featured at various agile conferences and events. Now, not all of that is true, but it's about 80% correct. And likely if we typed any of our names, we would get something along those lines. So let me attempt to replace a manager. ChatGPT, by the way, ChatGPT recently passed the United States board medical test to be a licensed doctor. And in fact, passed with a near perfect score. So apparently, if you give the correct amount of information to ChatGPT, it has a higher percentage correct diagnosis than your average physician in the USA. Also, ChatGPT, you can type essentially any homework question into it and receive a passing answer. So the idea of homework and the idea of oral or written board certifications are becoming strange now because of the level of skill involved. So let me type a question. Maybe I would ask my a manager. Should I take vacation next week? As an AI language model, I'm not aware of your personal circumstances, work schedule, or any other relevant factors that may influence your decision to take a vacation next week. Now, this is important. The advantage of what Tesla does with digital self-management is their apps do have all that information. They know your work schedule. They know the workload coming around you. They know inbound logistics, outbound logistics, current defect rate. They know the speed of the group you're working with, when you're in it and when you're not, and when various other people are mixed in or mixed out. It's aware of all of those things. So it actually has a very rich data set, whereas OpenAI here doesn't, right? However, taking a break from work and going on vacation can have many benefits, such as reducing stress, improving mental and physical health, and increasing productivity upon return. Before making a decision, you should consider your workload, upcoming deadlines, and any commitments you have at work in your personal life. You should also check with your employer or supervisor to ensure that taking time off is feasible and that your absence will not cause any disruptions to ongoing projects. Ultimately, the decision to take a vacation is a personal one that depends on your individual circumstances and preferences. If you feel that a vacation would benefit you and you're able to take time off, then it might be worth considering. Already you can imagine an AI of this level, if it were armed with more information about your circumstance, might be able to make a recommendation in even using supporting and encouraging language as well as most humans, and much better than a human on a busy, bad day. So could an AI actually coach you to improve? What should I do to improve in my teamwork at work? Improving your teamwork skills can help you become a more valuable and effective member of your teamwork. Here are some tips to help you improve your teamwork skills. Communicate effectively. Effective communication is key to good teamwork. Make sure you are clear and concise when communicating with your team members and actively listen to their feedback and suggestions. Build trust. Trust is essential for effective teamwork. Skipping. Develop your interpersonal skills. Skipping. Be proactive. Skipping. Embrace diversity. Skipping. Celebrate success. Skipping. Remember, improving teamwork skills takes time and effort. Focus on developing these skills consistently over time and seek feedback from your team members to ensure you're making progress. Not bad. Not bad. If a human manager told me those things that clearly, that'd be pretty good. And it might take them 90 minutes. The real advantage here is how fast that comes. So let me stop sharing ChatGPT and go to a Miro board. Now, I created a 12-step program of the Musk model, except I don't think anyone can call it the Musk model except Elon, and I don't think I understand all of it. So I call it Joe DX. It's as much of the Musk model as I was able to understand when I was working for Elon. And part of that 12-step program is digital self-management. And that's what I want to get on the record here and through this recording, make part of the lean community, the agile community, the business process community. Digital self-management, DSM. When I was working for Elon, we would all very often say, there are no bosses. Your manager is data. What that meant is you didn't ask your boss, should this robot have this torque specification actuator or that torque specification actuator? You would ask data that question. You'd create a learning model, you'd run a gradient descent, you'd have random reset to avoid local minima, and you would have the data unearth how much torque is truly correct according to what's known about physics for that actuator. All questions are data questions. So what's left for a manager to do? Okay, we'll leave that question a little later. Digital self-management. I'm not sure why managers and departments are even mentioned in Tesla's onboarding documentation called the Anti-Handbook Handbook. Maybe it's from an older version, because managers and departments don't exist in the normal sense, or at least I didn't experience them at all. As mentioned, I had a manager that was assigned to me, but who that person was rotated, sometimes more than once a day. And departments are completely permeable. You largely do work in a large room with many different skilled people, and you intermix. There's no mechanical engineering department. There's nothing like that. There's people with mechanical engineering skill mixing around. It's more like attending an open space conference. And any approval that waits for a manager is automated by software. This software has largely replaced management. This software is called digital self-management and allows for nearly 100% of staff to be an engineer, directly improving the products every day. This improves financial efficiency. Replacing human decision points with apps is the digital backbone of a modern company and fundamentally determines the speed of product development and response. Hashtag digital self-management, or hashtag DSM, means saying, why would we ever ask a human to do this? And being honest. I have a link to a YouTube video here that was also included in the preparation materials for this talk. Now, where does the data set come from to make, we hope, good decisions? Large farms run materials tests and other long tests. These farms create a library of material wear characteristics, which is used to simulate part testing in seconds. This data feeds AIs to help make design decisions. Physical testing is never a gating test or dependency, it's just too slow. Digital twin analytics. Every Tesla and every SpaceX rocket reports its current location, speed, temperature, even the number of occupants, and what position in which they are sitting. Tesla employees cannot see who is in the car or who owns the car. There are 3 million Teslas on the road now. Actually, 4 million. Tesla just passed the 4 million mark last week. Tesla keeps a complete CAD model of every car and updates that CAD model with likely wear characteristics or changes based on the real-time analytics from each car. This allows for proactive part replacement and suggested design updates. So the AIs proactively suggest design updates based on simulations of what may be wearing out, wearing thin, etc., in different areas of the cars based on how they're actually being used. An iteration review in hardware means hardware is fully tested, homologated, certified, and in production. This means every single car and rocket puts itself through automated testing of every non-destructive compliance and certification test. This is called factory mode, and it's where autopilot came from. Speed of certification dictates iteration speed. Here's an actual picture of what displays on the cars as they go through the factory and they're running their own regression tests as they're being assembled. Here is a picture that was released just that last week of the latest version of factory mode. Modules of the car are individually tested and regression tested in factory mode, then tested again as soon as they are connected to the car. Here, the steering column, dashboard, and interior package are regression testing and testing connectivity to each other. Are they correctly installed? Are they behaving appropriately? They're putting themselves through a full suite. This car will be tested as road legal or not by the time it's assembled. This individual car, and they all are. This is completely different than batch-based testing that most companies use, which limits how quickly they can introduce changes, because you cannot legally introduce a change faster than you can certify the product for production. So this massive investment in continuous road legalization and type certification is the only way to have no waiting for new product introduction. In the factory floor, that means there's no waiting to introduce new parts. And in fact, Tesla is famous for introducing new versions of parts multiple times a day. For example, the headlights, taillights, and charge port, including software, production, certification, and suppliers for the Model S and X car and SUV were changed in 2 days in production and sold to customers. That would be a 2.5-year change in any other automotive company. So how does that work in production? What's important is the definition of ready and definition of done tests. As you're inserting new hardware and new software continually in production, in volume, you need to be testing that that module retains compatibility, user acceptance testing, with the rest of the system. Here are pictures that were released just last week. What's the advantage? Why would you want to change that often in production? Why would that be a good idea? Here is the heating system of a previous version of the Tesla Model S sedan and Model X SUV. And for their price, the S sedan is the fastest accelerating sedan in the world for its price, and the Model X is the fastest accelerating SUV at any price in the world. Here's the diagram of the electrical system. Fairly normal. Nothing looks obviously wrong about it. In the next version of the product, it was a little bit simpler, a little bit more compact, a little less expensive. Without releasing a new model, simply during a production run that day, the Tesla engineers were able to switch to a heat pump. This is significantly less expensive, significantly more efficient, significantly lighter. That didn't have to wait for a new model. It was introduced the day it passed test. It became the volume part deployed in production. In fact, the day it was introduced, there was a mix of new and old sold the same day. They both had to be certified road legal, and every customer that bought those cars had to have at least the advertised range at the time they bought their car. A heat pump gives the car longer range, especially in cold or hot weather. So every car sold that day had to match the specifications advertised the day the car was purchased. But there's a mix of new and old version whenever these products are introduced, which happens multiple times a day. So why would you want to introduce new products rapidly without waiting for a model change? You realize the cost, range, safety advantage, whatever the advantage is, immediately. You reduce cost of waiting. So 100+ subcomponents were deleted. The evolution of the heat pump is on the production line. Because of digital self-management, you know if your part is road legal, and you know right away. That means you can test and learn in production. Design is in the same building as production. In fact, it's on the production floor and it's the same employees. There's not a different group of people that does design and another group of people that does production. They're mixed. Elon prefers small teams that are passionate and motivated for the mission. And he likes them all to be in one room whenever practical. So you have people with software skill, procurement skill, logistics skill, embedded software skill, mechanical engineering skill, supplier management, production skill on different machines in mixed teams. And because of that, you can start with 3D printing pieces of a heat pump in production. Some of these are sold if they pass all tests and durability tests, accelerated aging tests, etc. And then castings, metal castings are made on the floor by the same people. They're not sent out by someone to give you a casting mold 3 months later. It's machined today. It's ready in 4 hours or about that, depending on which casting type is being used. So you have sub-day castings being made, and they're semi-automated. AI is automatically suggesting changes to your casting model, and you're machining new castings as fast as you can, because that's simply the cost of aluminum. If you're doing it in-house, it's very cheap. It's simulated at the same time. You're simulating the heat pump's performance, the heat pump's aging, at the same time you're physically testing the last version you were able to make, which was probably a few hours old. And so you have simulation results branching automatically of new future designs. And just like when we write software, the deployment of software is automated, right? We use DevOps to deploy new software. Well, it's the same in agile hardware. When the heat pump design is significantly improved over the previous design, you've been testing with automation the entire time. Your production, even in prototyping, is automated the entire time. You simply ramp up the volume. You ramp up the number produced. It's already automated production. So when you design a part, you're simultaneously trying to design its production process fully automated. That's like modern software development, right? And it's absolutely the same in agile hardware. Now that is difficult. So you do it in rooms with many teams of cross-skilled people that are all helping each other. And in that way, in less than a day, it's possible. And that leads to continuous cost reduction. Now, these snapshots are taken yearly. This is happening continuously. So this is an overall trend. This is reduction of cost in the center console, the center display, for example. As the chips are changed, the wafers are changed, the production methods and materials are changed, the physical castings that hold it together onto the dashboard and are passing safety spec, all of these have to be tested as road legal every time. These are being changed as often as more than once a day. And in aggregate, what that means is cost drops. So most companies have what's called a minor model change cycle that's every 2.5 years. So a significant change has to wait at least 2.5 years to make it into production. And then a major model change every 5 to 7 years. So you can't realize significant cost savings or weight savings or power savings until you can introduce that part and test it and validate it. Well, if you've invested in continuous testing and validation through digital self-management, these are introduced in real time at any time. This is a result of digital self-management. You don't have to ask Elon, should I put the new heat pump in the car or the new center display in the car? If your automated test pass, that is your boss. You deploy immediately, and now you join what's called the production ramp, trying to increase the quantity. The cost reduction has, in aggregate of all parts, dropped the cost of the Model 3, which is the same model, 30% from 2018 to 2022. So faster than the major model cycle of any other car company on planet Earth, volume car maker. The company is able to knock 30% out of the cost. No one else in the world can do that. And that might be part of why the Tesla Model Y is the best-selling car in Germany again, and the highest rated safety car ever tested by Euro safety authorities. Now, these cost reductions do come from increasing volume, productivity, overhead efficiency, product improvements, engineering changes, localization, supplier scale. The useful point here is all of these are changing in real time. There's not a management initiative to Kaizen productivity. There's not a management initiative to ramp up supplier scale. These are continuous multiple time a day fights, engineering fights that are conducted by these mobs, these groups of people doing the work. And I'm very honored I've gotten to be in many of them. That was part of the work I got to actually do. And that isn't just an advantage to the company balance sheet, 30% cost savings, which yes, is reinvested back into engineering, back into R&D. So that does make it out to the customer, but it's directly noticed by the customer in charging times. For example, many customer facing features, which for electric cars, the primary facing feature is charging times. They're 30% quicker in less than the time of a major model change. No other car company on earth has this level of continuous improvement because they don't have the level of digital self-management that Tesla does. And that improves the employee experience. As the Model Y, the SUV, the best-selling car in the world right about now, Model Y output increases, the labor hours are dropping because these teams are continuously introducing better and better automation and reducing part count continuously. So notice, this isn't waiting for a major model change. This is daily. Daily, minutes or seconds are being knocked off the time it takes, the labor time it takes to produce these cars while the volume increases. This is the dream of an employee, and it's happening. And it's happening in the USA as well. Here's Fremont, California, where I worked most of the time, Model Y output versus Model Y labor hours. Same thing is happening. Again, what's important is to automatically test the definition of ready. Is your subassembly ready for another part to attach to it? And the definition of done. Is that part unit tested automatically to be your quality standard, road legal, etc.? And it's all because of powerful in-house software. You have continuous exploratory design and exploratory testing automatically running in real time as you draw CAD. And teams and teams and teams of people are doing this. There's no one person working on one part. It's at least 3 people on any given work item because we do the work in mob style, group style. We didn't call it mob in Tesla. We simply worked. But for those of you familiar with mob development, that is extremely similar. That's the closest I've seen that has a word to what I experienced working in Tesla. Now, these automated design helpers that are all in-house software, automatically feed the automation in manufacturing. And because the manufacturing is in-house, it feeds making new models, new parts that day. And if those new parts pass test, they are installed in customers' cars and sold that day. And no other car company on planet Earth does that. And in SpaceX's case, no other aerospace company on planet Earth does that. And it's not just Tesla and SpaceX. Neuralink hardware is a medical hardware implant. Neuralink improves their hardware every 45 minutes and is working to be faster. This is embeddable in the human brain, skull and brain, embedded medical devices applied for FDA approval, and they're changing in hardware every 45 minutes. Tests run on each module. The total system is also tested together by automated integration tests. The same people that design the hardware also run and respond to the automated tests. Engineers manage themselves by responding to automated product tests. Here's an excerpt from a Neuralink presentation. The quotation from this Neuralink employee. So firstly, we added large suites of acceptance tests to the manufacturing. When I talk about agile hardware, it's treating the hardware just like software. If you'd like to change hardware in a useful, valuable, high quality way more than once a day, you start by adding large suites of acceptance tests. And these are, of course, all automated. The engineers who design also work on the physical manufacturing. I'll say that more clearly. The engineers who write the automated tests also design the parts and respond to the automated tests by designing the parts to be better, to perform better in those tests, and they physically build them. This is like what we call full stack in software. An ideal software development team can design, build, test, and deploy and respond to defects in their product. That's the ideal software team, according to Facebook, according to Dropbox, according to LinkedIn, according to all of GAFA. So these incredibly successful software essential companies say full stack is the dream. It's the best. This is full stack hardware, and it obviously has the same result. 45 minutes in human brain embeddable devices. We then collect data from these implants, these medical implants, in this case in pigs and monkeys' brains, around the clock. It never stops. This data is processed and feeds back into our design process and empowers our engineers. So the engineers have simulated test and real test from the last version of implants continuously feeding their new design. They have mock brains of different levels of jelly-like material. A point made by the Neuralink team is the human brain, a pig brain, a monkey brain, they move. And they move at different layers. Like you could imagine looking down at layers of different clouds, and they're moving in different ways, and wiggling and jiggling. So the benchtop testing was to make a multi-layered brain that out of different substrates, different gels and plastics, that moves in a similar way and can be agitated to move and to continue moving in a similar way to these actual real living biological brains, and continuously test that. So you have physical testing in rubber and gel constantly. It never ends. And it's constantly the new version of the probes that slide into the brain are being tested on the benchtop. You have simulation that never ends, and you have feedback from the last version that was embedded. And by having a large enough pool of apes and pigs, you continually have a new version being inserted at any given time. And the real-time data of that Neuralink is compared to previous versions that are also still in other pigs and other apes. A key important part is the Neuralink is able to be removed with no damage. So every so many pigs and apes, the Neuralink is removed to verify full recovery, and a different Neuralink can then be reinserted. So you have failback and redeploy, just like you'd want in great software. To iterate in under an hour for new designs, allowing several iterations per day. This is the needle, essentially, that needs to puncture the thicker blood-brain barrier without breaking, and then be so thin that it can quickly and accurately find its destination in the correct point in the brain. So you have a strength requirement, a data connectivity and high-speed bandwidth requirement, and then a absolutely minuscule wish. And these are, of course, at odds. You know, engineers say, look, this is going to take a number of years because we have competing priorities. Well, digital self-management allows you to do a test and learn approach with multiple tests a day. And it simply wins. It simply wins over multi-year long engineering research projects that are not managed to be iterative. The whole goal is to iterate faster at all levels. Iterate faster on the benchtop, faster in simulation, faster in deployment. Now, interestingly, you'd think with software managing employees, they'd be less engaged. What Tesla Human Resources is reporting is that as employee engagement increases, safety improves. So the digital self-management has been optimized not to manage you against your will, but to show you how to improve if you want to. So the DSM doesn't do your performance review for you. In fact, I never saw a performance review when I worked in Tesla. I've reached out to other people who are still working in Musk companies to say, are there even performance reviews? I never even saw one. It seems to just not be an activity that anyone cares about. You make a lot of money on stock, so the financial wish for performance review is less important. So the DSM is not doing your performance review. The DSM is saying, if you want to do a better job, here's likely how to do it. That is motivating. By optimizing the DSM for employee motivation and checking employee reported motivation and engagement, even safety improves. The bottom line is Tesla AR's piece, Tesla Human Resources. Would you like to know more about Tesla's in-house software? There's a news article earlier that goes through many of the different software stacks in use in Tesla, for example, Warp. And here's a screenshot from my actual mobile phone. These are the apps that I had installed in 2020 when I joined the company in 4 hours. The first 4 hours of my employment, like anybody, you get these apps, these DSM apps. It's multiple apps, it's not one. Among Tesla's many homemade business applications is a purchasing order system called Warp, previously known as Warp Drive. Warp is also used for car work orders and service centers. Besides Warp, has several other programs, including TMOS, MES, Garage, and some of these descriptions, the news article didn't get quite right. They're used in all aspects. In summary, the goal is for 100% of staff to be engineers in hardware and software. Any work that requires taking someone away from engineering is automated as much as practical. The result is a high financial efficiency for the company. So what happens if you have great management skill, great people skill? You're not so good at doing hands-on engineering anymore. You haven't practiced it, or maybe you never were a hands-on engineer. What would you do in a company run with DSM? You join the engineering again. And that's why the work is group work with this high forgiveness culture, this welcoming culture. Sure, you might not be familiar with this skill set. Come in with the 3 of us. One of us is really good at this, and the rest of us are curious. We'll rotate turns. We'll all give each other encouragement and advice. When it's your turn, we might have to tell you exactly what to do. That's okay. It's clarifying our process to tell you as you do it. And if you hang in there for 10 hours or more, you'll probably learn all the basics. And if you hang in there for 100 hours or more, not in one day, it's not, the work hours aren't that brutal, but if you hang in there for 100 hours or more, you'll probably be pretty good at least part of this. Everyone's job is to be a worker. Everyone's job is to be a hands-on engineer, including Elon. Elon joins the mobs 12 or more hours every day, directly doing the work. I'm Joe Justice with the Agile Business Institute. I teach Joe DX. It's the best I've learned how to describe the Musk model. The Joe DX course is a 12-step program taught across 2 days. I'm experimenting with a 4-day product. in all time zones. I have classes coming up in Europe, Asia, and the Americas time zones, which covers most of the earth, and people working a little off time zone are usually able to take them okay. The class has been taken by representatives of all the world's major aerospace and automotive companies. So it's been very well received and very well tuned. I hope some of you will enjoy it. And this part is going out to YouTube. So you at least got 1/12 already. You can read my book if you really want to. It's Scrum Master by Joe Justice. I'm on Twitter @Joe Justice, and I'd love to connect on LinkedIn, Zing, Facebook, and Twitter.
Thank you very much, Joe. Fascinating. I'm always fascinated. I take a billion notes as I'm going. Thank you very much. Do we have any immediate questions or comments that somebody would like to share?
Yes, please. Yeah, anybody, go right ahead.
Yeah, I made a comment in the chat, it's Christer here, just to expand a little bit on what you said with Tesla reducing the cost with 30% on the Model 3. I just added a comment that they don't decontent when they are reducing the cost.
What do you mean by that, Christian? I'm not sure the word decontent.
Yeah, they are not taking out content features
Okay.
or something that is valuable for the customer. On the contrary, they are increasing the value for the customer.
Yeah, a lot of companies, when they want to reduce cost, they the switches that make the windows go up and down. If you're in the back seat, you have to hold it up and hold it down. If you're in the passenger seat, you have to hold it up and hold it down. And sometimes even the driver's seat, you have to hold it up and hold it down. And like, why? That'd be another 10 cents a switch, if even, right? And the Musk companies are not doing that. In fact, the feature content, the customer visible feature content only goes up. As soon as a innovation is made in suspension or performance, it's deployed across all vehicles. They don't introduce some new luxury trim and have a decontented, a less feature-rich, lower trim. I'm really glad you made that point, Christer. Thank you.
Other comments?
Hey, Joe,
Go ahead.
Joe, this is Don Tar calling. Thanks a lot. It was really, really interesting hearing what you had to say. As you're going through the no manager piece, I was reflecting. It seems like in my time managing in a company that 80% of the issues at work are people issues. How does that relate in your experience in the Musk companies? And how do you deal with the people issues? Because I can't imagine there just aren't any. So who deals with them, and how do you address that?
For sure. Okay, there is human resources or agile people operations. In fact, there are even two groups. So if you had a people issue that you wanted trained coaches, mentors, facilitators to participate in helping you resolve, you could do that anytime. You could ask them through chat, you could ask them through email, you could walk over and talk to them, and they're physically there. The Musk companies, you might remember, have banned remote work. That's highly controversial. It does work. It's also highly controversial. An effect of that is that you have physical human resources professionals very near you at all times. So you have that access. Now, some of that you can ask DSM how to resolve these issues, but I'll say the culture of the company has made it better than I've experienced other places because the people aren't measured, the product is. In a lot of companies, you have competing designs for a new battery pack. And whichever team has their designs picked are more likely to get a promotion, and the other group are less likely to get a promotion. So you have people issues emerging out of this competition and tension. And people are incented to win, whether or not their product is really even the best. So they want to look good and make friends with the right people and make the other people look less good. And that stresses relationships. You have a competing relationship, right? I won't say that never happens in Tesla, but it's different because no one cares who made the battery pack. The only issue is, did the DSM say this is the better option we have right now? And then everyone immediately swarms on whichever version DSM currently validates as best. You can have long running experiments to make something better or cooler. And DSM will say, look, it's not better yet. It's not better yet. That's all right. You can maintain that. But you never have to win and convince anybody you won. You just have to have DSM show that it finally became the superior version at some point. That's it. By not measuring the people, there's no utilization. There's no utilization number on me, how many projects I'm on, none of that. Instead, is the heat pump drawing less power? Is the heat pump having fewer failures in the field? Like, that's it. And that difference in focus makes more often the focus on the product and the engineering, and it pulls away some of the people issues that I've experienced in other companies. I won't say there's zero people issues. I don't think that's possible, but it's much less than I've experienced elsewhere. Donter, did that get towards your point, or did I misunderstand you?
No, it's great. I mean, I think, as I think as being an engineer, you want to do engineering work, and a lot of times we get sucked out of that. It's just that as you get multiple people together, there's going to be issues that arise. And that's where you seem to see the majority of issues that come up in most companies. So thanks for answering.
For sure.
That's
For
good.
sure. Another helping hand here is how quickly you feel success. In a traditionally managed organization where you have multi-year projects, often you don't feel success for multiple years. And even then, your product isn't always used. And even then, you might have done the validation on a sub-assembly. So it's hard to have that pride of engineering. But if you're in a company that's introducing improved versions of the charge port multiple times a day, every time you release and the DSM shows it's a superior version, you get this empowerment, this feeling like you scored a point. And that also reduces some of the potential frustrations that can lead to people issues. You're truly having a good time doing engineering. That also seems to help. I don't mean to say it's a perfect utopia, but I will very clearly say I've never worked in a company that was more fun to work in as someone who likes to build stuff.
Har has his hand up. Per, you have a question?
Har, please go ahead. Har, I don't hear you.
Okay.
Is your microphone
Yeah.
enabled? Oh yeah, please go ahead.
No. How about Rudy? Rudy, you seem to have your question for us.
Yeah, I have. Hello, Joe. First of all, I should say I'm very new to this agile context, and I find you very inspiring. I've listened to a few of your talks, and I find it extremely inspiring. There is quite much details into what you talk about, so that makes it even. I mean, it's easy to grasp, even though it's very kind of artificial for some of us working in old legacy companies, right? But I have collected two questions, and you said in the beginning about being data driven, how that is. I mean, that's the engine of the DSM. You mentioned it several times. And my first question is, where would you start if you don't have? I mean, many companies have the data not collected, not bound together, not trained in a neural network, etc. So where would you start if you come from a legacy company wanting to try out this route? That would be my first question. My second question would be, when it comes to shorten the feedback loops, we talk about AI determining test results. I heard you talk about painting robots and camera angles, etc. Where would you say it is most difficult to accelerate and not use time as provider of the test result? Where is the most difficult area? Those two questions I have for you.
I might need to ask you a question about the second one, but let me try to get to the first one first.
Yeah.
Where to start? From a test perspective, your question seemed to be triggered or engaged by the testing part. Where to start with tests, it would be, where is a place people wait? And truly anyone, because some of those will be really difficult as a starting point. And typically we wait a lot, especially in a legacy company, you know, with a multi-year project. Often we have many different kinds of wait states. So let's look at one and say, can we automate what we're waiting on? And the answer might be no. So we look at the next one. And the answer might be no. So we look at the next one. We want to find at least one. And that's where we start. The wait state could be as simple as vacation approval. Okay, well, can we stand up a vacation tracker gradient descent algorithm and give it just the most rudimentary data like calendars and let it start to try to make guesses, and then run that alongside the human system that's currently making those approvals? Was the AI at least not worse? It doesn't have to be perfect. Is it at least not worse? Even if it's as good, not at all better? Is it fast? Done, switch over.
Yeah,
Switch
we
over.
thought of I had a thinking of doing that for travel approval. We have to get approvals from different directions when we go travel. That was, so it was a good example that you gave. Thanks.
Maybe. Now there's a trick
Yeah.
there. We're in a legal, I don't want to say even gray zone, a legal new zone. What's accountable when an AI makes a mistake, right? So what needs to happen is a manager, someone who's legally accountable, like accountable to the unions, accountable to the law. They need to say, I take responsibility for that algorithm. That is actually the huge gift that Elon gives to Elon's companies. Elon says, I will go to court over what this company's doing, and Elon does. I don't know how many of you follow Elon's schedule. I do, because it's fascinating. The person is incredibly skillful, being in a senior position in 5 global leading companies, all the highest valued of their type in the world. So something interesting is going on. Elon almost every morning is in court, and almost every afternoon is in mobs doing group work, engineering work, until 1, 2 a.m. almost every day, 7 days a week. Now, that's very durable, and there's some other things about sustainable pace. That's another topic entirely. But what I want to say is someone needs to be going to court over this stuff all the time, because new tech goes to court all the time. So even if it's just vacation policy or travel policy, when someone's mad and has a union grievance or something else, what happens? They're in the current world, a human needs to say, I endorse this algorithm. I will respond to any union grievance. So that gets to maybe the better place to start is ask for permission. Can these 90 people try this for 90 days? Like something like that. Bigger is better, longer is better, but anything you can get. Can just I try this for 1 hour, right? Anything. We'll start with anything. And if you get written permission from someone who could actually go to court over it, who would go to court over it, then you can start. And that seems to be the freezing point for most traditional legacy companies. No one is brave enough yet. But finding that person seems to be your radical enabler.
Thank you, Joe. Thank you very much. Bravery, I think that's a great word for it, because as I listen and I think about, I wish we had such a thing. I've got to be the one that does it. I think it seems like that's what happens at Tesla is, and then I need leadership to back me, to say, Joff, he knows that we need this system and he wants to get it going. Let's help Joff get that system going. So I think this is a good transition to our next speaker, Christer Lund, and he's going to talk about extreme ownership.